Implant mixed-mode brittle fracture assessment of Harsin marble using HCSP specimen. The primary aim is to study the effect of TS term on the fracture parameters of implant mixed-mode loading by utilizing GSED within a new proposed sample, namely HCSP. TS is the first non-singular high-order term that depends on the geometry and loading configurations. Fracture parameters of implant mixed-mode, especially dominant mode 2 angles, are variable relative to value and sign of TS. GSED was proposed in order to predict fracture parameters more accurately in mixed-mode loading. GSED considered the effect of critical radius and TS besides singular terms. HCSP is characterized by a substantial negative TS in mode 2 dominant angles. Fracture parameters of HCSP is dependent on sign and value of TS. Crack inclination angle were set to desired angle to investigate brittle fracture for covering the entire range of implant mixed mode. Specimens were fabricated from white Harsin marble. Within a simple apparatus were exposed under tensile load. The crack propagation angle predicted by HCSED are highly consistent with the observed fracture angle of broken HCSP. The TSRs led to discrepancy between experimental results and SED, especially in mode 2 dominant angles. The deviation between SED with new experimental results is eliminated by utilizing GSED, which is considering the influence of non-singular terms. Also, the effect of TSRs is more pronounced for materials having larger value of critical radius. Large value of TSRs and large critical radius led to inconsistency among the experimental records and the results predicted using SED. Experimental fracture parameters exposed to mixed mode loading are in acceptable consistency with GSED.